This is AQA A-Level Chemistry and we are looking at the Year 12 topic Alkenes. This is part 1 of the series, and in this we're going to take a look at nomenclature and isomerism within alkenes. Okay, I'm going to recommend that you try each section, pausing as you go, and then you can check your own knowledge progress and understanding. So in the first instance, we need to know what an alkene is, the types of isomerism that we might see, and we also need to look at the reactivity of alkenes, which will be ongoing through the rest of the videos in this series. But to start off with here, we've got some good information about keywords, homologous series, functional groups, and something that came up in the alkanes topic: can we find the 4 characteristics of the homologous series of alkenes, and in fact the 4 characteristics of any homologous series. Okay, so the first one is that they have the same functional group, and I've highlighted those here. We can see they all have the double bond. Now they also all have the same general formula. They're all CnH2n. And if we think about their reactivity, they're going to have not the same chemical properties, but they will be similar. For example, you will be familiar with the reaction of alkenes with bromine, and that will be common to all of them. And finally, you can say that each of them differs from the next by CH2. I would be focusing, if we were picking 2 of these 4, on having the same functional group and similar chemical properties. So, already touched on this a little, but alkenes are unsaturated. What is the test for unsaturation? So, if you've had a chance to think about it, you add bromine water. And if we think about the observation that we'll make with an alkene, it's important to note that the bromine water starts as brown and it then gets decolorized by alkenes. So the brown colour turns to colourless. Now, the key word that you must avoid here is clear. You cannot say the bromine water goes clear. You can say decolorized or goes colourless. Some practice nomenclature now. Try and draw these out and see how you do. So pent-2-ene, pent we know is 5 carbons, and we need to learn that. So we have 5 carbons in a row, and the fact that it's 2-ene tells us that our double bond starts at the 2nd carbon in the chain. So I'm going to add my double bond. All I then need to do is add all of my remaining hydrogens. And remember that each carbon forms 4 bonds, so you can see that that's what's happened. Be particularly careful around the double bond, that I've only put 1 above, not below, on each side, because this carbon has now got 2, 3, 4 bonds, and this carbon has got 2, 3, 4 bonds. So let's try cyclopentane. We again know that this is 5 carbons in a row, but it's cyclo, so it tells us we're going into a ring structure. So we have got here our 5 carbons. Each of those carbons can now have 2 hydrogens connected, so I've got my structure completed. If we look at C, 3-methyl-but-1-ene, well, but tells us the longest carbon chain is 4. We also know that the alkene starts at the 1st carbon, so my double bond goes between the 1st and the 2nd carbon. And I have then got a methyl group, which is a CH3, and that's coming off the 3rd carbon. So if this is carbon number 1, we go 2, 3, and we add the methyl group on. We then fill up the remaining gaps with hydrogens, and I've got those here. We're going to move on and take a look at 2-methyl-but-2-ene. So once again, we have but, which is 4. We've got our alkene starting at the 2nd carbon, and we've got a methyl coming off the 2nd carbon. And then once again, we fill in the H's as I have done here. Finally, 2-methyl-but-1-ene. So I start with my root, my 4 carbons in a row. I've got my ene at carbon number 1, so going between carbon 1 and 2, and then I've got a methyl group on my position number 2, so I add that in. I've then got my remaining H's, 2 here, 2 here, and 3 here. What type of isomerism are we seeing in these? Well, let's go back to that once again. These are all structural isomers of one another. You could argue that we have chain isomers, C, D, E, or certainly C and E are chain isomers because the only thing that's different is the carbon chain. C and D are positional isomers because the functional group is in a different position. And if we compare B to any of the others, they would be a functional group isomer because B is a cycloalkane and the other is an alkene. So we are looking at structural, but we've seen all examples of structural isomerism as discussed in the alkanes topic on there. Now, isomer 1 can exist as E and Z stereoisomers. What do we mean by the term stereoisomers? What we mean is instead of, we can see there that structural isomerism is same molecular formula, different structural formula. For stereoisomerism, we start with the same structural formula. So the structural formula is identical. So we've then got to remember what's different. And there's different ways you can say this. You can talk about there being a different arrangement in space or a different spatial arrangement. So let's put that into context and try to come up with the EZ isomers of pent-2-ene. Well, in the first instance, let's draw pent-2-ene to see what it looks like. Pent is 5, so 5 carbons in a row. My double bond, my carbon-carbon double bond starts at my second carbon, and then I fill in the remaining H's, and I've added those in here. What I'm then going to do is colour code the 4 different groups that come away from the double bond. So I've got those here. I've got my yellow H, my green H, my pink ethyl and my blue methyl. And we're going to draw this in a slightly different way because when you want to show geometrical isomerism or stereoisomerism, it's always good to have your double bond at the centre with 4 groups coming away. Now, when you want to decide if something is a stereoisomer or not, you can ask yourself 3 questions. And if you get 3 ticks and 3 yeses, then you can be confident that there are geometrical or stereoisomers. First of all, does it have a double bond? And it does. There's a tick for that right there. You've then got to look at the carbon on the left of the double bond. Does it have 2 different groups coming from it? This has an H and a CH3. Second tick. And on the right hand side, does that carbon have 2 different groups coming from it? We have an H and a C2H5. Tick. 3 ticks. This tells us it does show stereoisomerism. So I'm going to put all of these here and we need to decide if this is E or Z. Now it comes from German words entgegen, opposite, and zusammen, together. And what we've got to consider is what is together. And you look at the proton numbers and you add up the atomic numbers for each carbon. So in this case, I'm comparing H to CH3, and for this carbon, I'm comparing H to C2H5. And in both cases, H will be a lower value than their counterpart. So H, lower value than CH3, H, lower value than C2H5. So our 2 lower values are both above the double bond. They're together. And for that reason, we have Z pent-2-ene. So how would we go about drawing E pent-2-ene? Well, you're going to take, you can see here that I've kept my H in the same position, I've kept my C2H5 in the same position, but I've swapped the position of the H and CH3. I could just as easily have swapped my green and pink groups instead. Because what this has now done is taken my lowest value in terms of atomic numbers and it's above the double bond on the right hand side and it's below the double bond on the left hand side. So they are on opposite sides. And that means E entgegen pent-2-ene. So we have Z pent-2-ene and E pent-2-ene. Let's take a look at a quick question here for you to think about. How could we distinguish between pent-2-ene and cyclopentane? Well, hopefully what you're recognising is that we're essentially looking at an alkene and a cycloalkane, so we want the test for alkenes. So we add bromine water. When we add bromine water, it will decolorize in the presence of pent-2-ene. You can't stop there. We also need to say that there will be no visible change when it's added to cyclopentane. It won't be decolorized. And we'll learn a little bit more about why that decolorization happens later within this topic. That takes us to the end of this section. Thank you for listening. Goodbye.